In this question, I'm asking you to provide a mechanism for how this secondary alcohol turns into this alkene when treated with aqueous sulfuric acid. So remember, I'm going to keep repeating myself when it comes to this. Every time you're asked for a mechanism, don't worry about major product. Don't worry about minor product. Your only goal is to explain how these reagents turned into this specific product here. Okay, so we always want to be working towards this product here. All right. So let's go ahead and just draw this structure out. Sorry, it's not as neat. I'm going to keep saying that. All right. So let's think about what's going on here. So we have sulfuric acid in here. Right. So what's going to happen here is the electrons on oxygen of the alcohol, they're going to grab this proton. Remember, always move the electrons from negative to positive. That hydrogen has a partial positive charge. Those electrons are negative. Once that hydrogen is grabbed, the two electrons between hydrogen and oxygen, they're going to stay behind on oxygen. That's going to be the conjugate base. We don't need to draw that though. Right? That's going to give me this protonated alcohol, an alkyloxonium ion. We got to think about what can happen next. All right. So we have oxygen with positive charge on a secondary carbon capable of forming a carbocation. What will happen is that oxygen will grab those two bonding electrons and leave. It leaves as a good leaving group. It leaves as a neutral water molecule. All right. That's going to form this carbocation right here. Right? Now that's a secondary carbocation. And anytime we form a secondary carbocation, we have to be aware if there's a possibility for a shift to occur. If the shift can form a tertiary carbocation. Well, again, we want to keep moving towards product. And we can see the double bond is in this position right here on the product. We can't get that double bond there if the positive charge is over here. So that positive charge must have been on one of these two carbons here, right? So there must have been a shift that occurred. So I'm going to draw this hydrogen in. And what's going to happen is those electrons between the carbon and the hydrogen, they're going to move over here. And when they move to that carbon, they take the hydrogen with them. That's going to end up forming this carbocation. That's going to put the positive charge on that carbon right there. That is a tertiary carbocation. So we made a secondary into a tertiary carbocation. That's a stabilizing situation. Now, we want that double bond to form right here. This positive charge is going to cause any adjacent protons to be more acidic. So these two are going to be more acidic, and these two are more acidic, and this one right here is more acidic. And any one of those can be removed. But we got to form this product up here. So we want that double bond there, which means it must have been the proton on this carbon that gets removed. So something in here is going to act as a base. It could be water, it could be an alcohol, could be the conjugate base of sulfuric acid. Something in here with lone pair electrons is going to act as a base. I'm just showing water doing it. It's going to grab that hydrogen. Those two electrons are going to move here to form that double bond. And that is going to take us to the product we're being asked for, which is that product right there. So that is a logical mechanism for how this alcohol, when treated with aqueous acid, turned into specifically this alkene.